Hey guys, how you doing? It's Coach Scott. We're on the fourth video in this series on the mole relationship. We're getting almost, you can call it stoichiometry too, but it's a big word. We'll talk about those later. But anyway, let's talk about percent composition. Now we're getting into really about some of the hardest math we're going to get into, and it's not that hard if you go follow the steps. So, why do we use percent composition? All right, this allows us to calculate, we know how to calculate the molar mass of material if we know its formula. How do we determine the formula? All right, what do we don't know what it is? That's what we're using percent composition for. And we're going to be using the tools that we've learned over the last week or so. And we'll be able to determine the composition of that substance if we've got some information with us to help us do that, right? So, one of these is percent composition, or the percentage of a compound's mass made up of various elements, right? Now we know one little secret. If I add all the parts of a pie, how many percent is that pie? 100%, right? So if I got 26.8% of chrome, 32.9% of oxygen, and 40.3% of potassium, what's the percentage? It's 100. Okay? So that's good. So, the percent by mass of an element in a compound is the number of grams of that element divided by the mass in grams of the compound multiplied by 100%. So, let's go back to the previous slide. If I've got 26.8% of chrome, all right, let's use that example. The number of atoms, or the atomic weight, the formula weight of the compound times 100 would be the grams of that element. That's a little complicated. Let's play with this one. So, we're looking at ethane, the percent of carbon in the ethane and the percent of hydrogen in the ethane, right? So, I've got C2H6. Well, the molar mass or the atomic mass of carbon is 12 AMU. I've got 2 atoms of carbon. The total mass of that molecule is 38 AMU. 24 plus 6 for the hydrogen. So that percentage is going to be 80%. The percent of hydrogen would be 6 atoms of hydrogen times the mass of each of those atoms, which is 1 AMU, divided by the percentage, the total of that mass. That would be 20%. So, ethane is only got carbon and hydrogen. So, if I find the carbon at 80%, the rest has to be 20. So I can do a little math that way. I don't have to calculate everything. 100 minus 80 is 20, or 20%. So, we know now that the percent of hydrogen in ethane is 20%, and the percent of carbon in ethane is 80%. Now, we've got more atoms of hydrogen in ethane, but by mass, the carbon's way more, right? So there's going to be more of a percentage of carbon by mass than hydrogen, okay? Carbon atom is 12 AMU. It's more massive than hydrogen with 1 AMU. That's why carbon has more of a percentage of the mass than hydrogen in ethane. So, in H2O, hydrogen has a mass of 1 AMU, 2 hydrogen, that's 2. Oxygen, there's only 1 atom, but it has a mass of 16. Which one is going to influence the mass more? Think about it. Of course, you're going to come up with B, oxygen. What's the mass percent of oxygen in water? Well, I'll have to do a little calculation for that. but it's not a hard calculation. So the mass of oxygen is 16 AMU. The mass of hydrogen is 2 AMU. Let's put hydrogen here, oxygen there, because there's 2 hydrogens. It has a total mass of 18 AMU for H2O. So if I have 16 divided by 18, the mass of oxygen, right, divided by the total mass of the water, put oxygen, then H2O. Then I take my calculator, 16 divided by 18 times 100, that's going to give me 88.8. That's the closest one. Actually, I'd probably round up to 88.9, but you know what I'm doing. B. What's the percent by mass of carbon in acetone? We'll do more of these in class. Well, I've got to find the total mass. So I've got CHO. I've got 3 carbons. It has a mass of 12 AMU. I've got 6 hydrogen. It has a mass of 1. I've got 1 oxygen. It has a mass of 16. That's going to be 36 AMU, 6 and 16. It's going to be 8. That's going to be 58 AMU. So the percent of mass, that's going to be 36. The mass of carbon, I've got 3 carbons. What's this say? Carbon. Divided by the total mass. Total mass. So that's going to be clear. 36 divided by 58 times 100, or 62%. Easy peasy, guys. Easy peasy. Let's do this in class. Okay, there you're going to have to know the formulas. We'll do those in class. So, talk about some real world applications. We've got aluminum in my soda cans, right? We've got aluminum in aircraft frames, and then also now they're putting aluminum automotive engines. Why? All right, because it has a less dense metal. Now, aluminum demand is increasing. Why? Because people like that light metal, and they made it strong. Aluminum comes from an ore called bauxite, which is 12% aluminum by mass. So, how much ore, bauxite ore, in grams must be mined to provide enough aluminum to make a car engine requiring 100 kilograms of aluminum? So, I'm going to start with 100 kilograms of aluminum, times, let's see right now, 100 kilograms of aluminum times, and I'm going to set this up in 1,000 grams in 1 kilogram, times 100 grams of ore, 12 grams of aluminum. Where did I get that? Well, there's 12% aluminum in 100 grams of ore, or 100% of the ore. So I can call that grams, and that's pretty well right. So if I multiply that out, I'm going to need 830,000 grams of ore. That's a lot of ore. That's 830 kilos. That's a bunch. We'll do that in class. We'll do that in class too. Okay, guys, so that's percent composition. And we're going to be using that a lot. Okay, and we may do a lab on that, or a demo or something. We'll work on it together. All right, guys, so this is Coach Scott saying have a great day. That's percent composition, and have a wonderful day. Bye.